Hello, everyone. Thanks for joining us for a special look at what our restoration teams are doing on a ship in the deep Gulf. My name is Sasha Brancis, and I'm the Gulf Restoration Education and Outreach Manager with National Marine Sanctuary Foundation, and I will be your host today. We're going to get to talk to our friends on a ship named Nancy Foster, which is a 186-foot vessel based in Charleston. And today they're about 180 kilometers or 112 miles off the coast of Gulfport, Mississippi. So throughout today's program, please share any questions or comments that come up in the chat, and we're going to pause for questions as we go. Also, we would love to get your feedback on today's program, so please fill out the survey to tell us a little bit about your experience before you log off today. And we'll send the link to the chat now, but then we'll send it again at the end of the program. So in just a few minutes, we'll connect with folks on board, but first we're going to talk about why they're out there and what we have going on out at sea. All right, so as you travel deeper in the ocean, less sunlight is able to penetrate the water. And just past recreational scuba diving limits, you reach the mesophotic zone, meaning middle light. Despite the low levels of sunlight, this zone is home to colorful corals, sponges, fish, and invertebrates. Beyond this twilight zone, there's no sunlight at all, as well as colder temperatures and higher pressure. But there's still vibrant habitats full of life at these depths, hundreds to thousands of feet below the surface. These mesophotic and deep benthic, or seafloor ecosystems, are found worldwide, including in the Gulf. That's actually where all this amazing footage is from. However, the 2010 Deepwater Horizon oil spill dealt a heavy blow to Gulf communities on land and at sea. 11 people lost their lives, and natural resources, wildlife, and habitats across the northern Gulf were severely impacted. Over 770 square miles of deep sea habitat were impacted by the spill. As a result, collaborative restoration projects are underway to help us understand and restore these seafloor ecosystems found below 160 feet deep. The projects are developing new and improved maps of the seafloor to locate important coral communities, learning more about the species that live in these habitats, the environmental conditions they thrive in, and how they may be connected across the Gulf. Determining the best methods to encourage deep sea coral growth and reproduction to help restore impacted coral species and the important habitat they create, and reducing the threats that these ecosystems face. Also, connecting the habitats and restoration work to the public and natural resource managers. This restoration work is made possible by the Deepwater Horizon Natural Resource Damage Assessment Open Ocean Trustees and is led by the National Oceanic and Atmospheric Administration, or NOAA, and the Department of the Interior, or DOI, plus many partners, including a large number of academic institutions and non-governmental organizations. So today we're going to meet some of those folks that we just talked about and hear more about the restoration work we just went over. So let's see if we can meet our guests working out at sea, the more exciting part. Hey, everyone.
Hello there.
Hi, Sasha.
How's it going?
Good. How are you?
Good. Is it a beautiful day today outside? Weather's nice out? Fantastic. I'm glad.
Great.
Yeah.
Very calm.
Very calm. Oh, that's all you can hope for. All right. So let's go around the room here and introduce yourself and tell us a little bit about what you're doing on board. And we'll dive into more of it, but just a little introduction.
All right. Hi there. I'm Max Woolsey. I'm an engineer with the University of Southern Mississippi, and I work with undersea vehicles and some of the landers that you're going to see.
Hi, everyone. I'm Celeste Friedemann. I'm a master's student at the University of Rhode Island, working with the landers.
Hello, everyone. My name is Andrew Davis. I'm a professor from the University of Rhode Island, and I build and deploy landers to better understand the environmental conditions in deep sea habitats.
Hi, everybody. My name is Philip Yang. I'm a PhD student at the University of Rhode Island as well. And I work with the landers to help understand deep habitats with the team here.
Awesome. And I think this is a pretty fun one today because almost everyone here is from URI. So I actually went to college at University of Rhode Island as well. And our team in the background supporting this live stream also is at University of Rhode Island. So pretty exciting to have us all together. Go Rody. All right. So I wanted to ask a few questions about what you're doing here out at sea, some of the important work you're doing, and the really cool stuff that you're working with. So, like I mentioned in the introduction to everyone, these habitats are pretty deep. So we need some special tools to collect this information. We can't just send divers really to many of the depths that we're working in. Some of them, yes, but we need some really special equipment to be able to see these habitats and collect information. So we mentioned landers. We got to see some sneak peeks of them in the introduction video. But could you explain to us what a benthic lander is and what kind of information it collects?
So so we get to work with a lot of cool equipment. We've got an ROV in the water right now that's looking around, scouting some of the areas, looking at where Andy's going to place one of the landers shortly. And we checked out one that's been in place for almost a year now?
Over, yeah.
Very cool. So we've got these ROVs, remotely operated vehicles that look around. We've got autonomous underwater vehicles, or AUVs, that perform mapping operations. But those are really only in the water a short time. But while we're out here operating, they're in the water mapping and looking around and taking samples of things down there. But in order to get an assessment of what's going on over long terms, we deploy seafloor landers, and they can stay there for a few months, for a year, for over a year, and collect data that we need to monitor what's going on.
Very cool. So what makes them such a good tool? I know you mentioned they can stay out a little bit longer, but what makes them a good tool for better understanding these deep Gulf habitats? Can we talk a little bit about like the kind of features that they have? And this looks like a really big one too.
Oh, definitely. That's one of Andy's Albeck's landers.
Yeah, so my lander is the big one with the orange balls that you can see on it there. And a lander is a really simple tool. It is essentially flotation plus weight. Everything is attached onto a frame. And we designed the lander to be very flexible, to collect a lot of different data streams and to hold a lot of different sensors. Because most of the expense and human effort in developing the lander goes into the deployment. So we want to maximize the amount of information that we can gather so that we can learn as much as we can about these sensitive deep sea habitats over extremely long time scales. So Albeck is a fairly unique platform. It's very large, about 8 foot tall, about 8 foot wide, and it's a tripod lander. So it has 3 points where it sits on the floor. So it essentially has a bit of self-leveling. If you've ever sat on a chair and it's a little bit wonky, a 3-legged stool, usually it's pretty stable. So we built the same thing with our lander there.
So you all designed it for exactly what you wanted it to do and exactly how you wanted it to be stable on the seafloor. That's really cool. Ooh, we got some good visuals of it underwater here. Wow, awesome. So we talked a little bit about what factors are going into choosing the lander design. It makes sense that it would be a lot more stable, and especially being like kind of large, but also wide. Hopefully it will stay put. So I know that there's other types of landers. So can you tell us like how long it takes to make a lander and how you determine what size to use and where? Because there seem to be a variety of different types.
The scientists always want more instruments on the landers. So, so part of how that goes is the engineers like myself work with the scientists to figure out what parameters need to be measured. And then we look at the instrumentation, build a frame that's large enough to carry the instrumentation. One thing you see is a lot of flotation on the landers. You're probably thinking, well, this thing just sits on the seafloor. Why does it need floats? But generally, yeah, there we go. There's one of the little models of the floats. So the landers are deployed to the seafloor, but then we communicate with the lander acoustically and have it release a weight when it's time for the lander to end its mission and come up to the surface. So we have expendable weights on the lander. It's the anchor that keeps it down. And so then the lander floats up to the surface. So we have to, first off, come up with a frame that is large enough to hold the instrumentation. We have to add floats to it so that the whole assembly will float when released. And then we have to add a big weight to it so that it will stay on the bottom. So it's a whole effort to balance the landers ballast-wise and absolute buoyancy so that we can leave the landers on the seafloor but have them come up when we need them to.
Awesome. And what, so on this mission, are you deploying them, retrieving them, both?
A little bit of column A, a little bit of column B. And so that involves prepping a lot of the instruments for deployment. And I know Phil and Celeste have both been out and preparing some of the instruments as recently as this morning.
Yeah, we deployed a lander yesterday. So we spent the last week or so prepping the lander on shore, putting the lander on the ship, and then continue to prep it on the ship. Here's a nice video of somebody taking, is that Jane? That's Jane working with the sediment trap. The sediment trap collects marine snow that's falling down through the water column, settling on the seafloor. So we can have an understanding of the particles that corals, which stay stationary on the seafloor, might be able to eat as they filter feed. So yeah, we're also about to recover a lander today, and we're going to deploy a lander before we recover. So we have a set of operations after we get off this live stream that we're pretty much fully prepared to do, which is great. So
Amazing. And so that sediment trap was like right in the middle of the large lander. Is that right? That white
yeah, it's
column?
the big white column.
Yep, so
Awesome.
part of the reason that lander is so large. So
Yeah.
so that lander has the big sediment trap in the middle. It has current meters. It has lights and camera to get video of interesting critters down there. And so the landers are just set up for pretty much the grab bag of all the science that you could get from this this long-term station monitoring.
Yeah, it's like a big tool belt full of all sorts of fun things that you might need. And so how long has that lander been down, the large one?
I believe it's been down for over a year now. When did we deploy it?
We deployed it last year, and Nancy Foster said we're picking up with the same shape as the one we put it down with.
Oh, very cool.
And
That's
Celeste, you were
great.
just working on some of the sensors as well.
Yeah, I was working on the sensors this morning. I programmed the CTD, the conductivity, temperature, and depth. It collects conductivity, temperature, and depth, and also fluorescence. And I programmed it to go off at midnight. So a lot of our sensors we pre-program and then we deploy, and then they should start. Oh, there's me and Ben setting up another CTD, a different type. The CTD was to get water quality water samples from the bottom that we use for the sediment trap.
Awesome. And so Celeste, that's what you're focused on really, is that CTD data. And you said that's connectivity, temperature, and depth. And there was another thing that you said you also collect with that. What was that?
Yeah, fluorescence or chlorophyll A. It kind of shows like how much fluorescence or how much photosynthesis is going on in the deep sea.
Ah, right. Which is interesting to know because a lot of these habitats we're working in are beyond the reach of sunlight. So we might still see things down there that you would normally see in a really sunlit zone, but it helps us to really understand how much light is penetrating down to these habitats, right?
That's a great video. That's our camera that's on the lander turning on with the lights turning on. And it only turns on once every hour for like 10 seconds.
Yeah, 10 seconds.
Yeah, so you guys will be picking that one up in the fall. And so you'll get to see the video from the other side. So we were watching the ROV looking at the lander. So in a few months, when we download the video from that, you'll see the ROV from the lander.
Yes.
And we'll definitely want to see that video, and hopefully we can share it to make a little video compilation to add to the playlist where we have these live streams, because I remember y'all being very excited when that deployed, that it happened to be right when the lights, the ROV was right in front of it, right when the lights were going off. And we rarely get visuals of the ROVs, the remotely operated vehicles that go down and collect a lot of video and photo content of these habitats, because they're the ones doing it. It's like me. When I'm at sea, I'm the one taking all the pictures and videos. So there's like never any pictures or videos of me. So
yeah, and when that one comes up, you're going to see a very special dance that the ROV did. I believe it's called the Robot.
Oh, I can't wait. That's fantastic. That's awesome. All right, we think we have a moment to see what questions we have here in the chat. Okay, we have some good questions here. How much does it cost to make a lander, and how many times will it be deployed during its useful life?
Well, there can be an entire range. Some of the landers that you guys have put together have been, very budget oriented and thrifty. Others that you've got everything in the kitchen sink. That's a wealth of instruments, because some of these places we can only visit once a year, and so
Yeah.
we put a lot of resources into it.
All the bells
What
and
have you
whistles.
got on that, Andy?
Yeah, to the Outback, the value in many landers is in the instrumentation that we put on, because the instruments are very specialized. They're made out of special metals and special materials. They're electronics. They're designed in such a way to ensure long life and long recording time. So a lot of the cost is from the instruments themselves. The frame and the lander platform itself is not super expensive, but the amount of times that we deploy these, so we protect the frames, we protect the instruments, we make sure that everything is very strong. We also use a lot of sacrificial metals to stop corrosion happening on the lander, so that we can continually redeploy it. I've deployed landers for up to 5 or 6 times before we start to see any minor kind of damage to the frame, and then we weld it, we repair it, and we put it back out. Some of the frames in my career have been used for 20 years.
Wow, that's amazing. And then, all of us working in ocean science, we definitely want to always be cognizant of repurposing things and making the most out of what we have and giving it a long life by repairing it. And that's awesome to hear. That's really cool. And I also want to mention too, like we talked about in the beginning of the live stream, all of this work is part of the Deepwater Horizon oil spill restoration. And so all of this work is being paid for by that oil spill settlement. So that's another great thing to know, is that the funds from the settlement are going to really good use to be able to support this work and learn so much more about these habitats. And I love that y'all are so handy building them and then also repairing them.
So many of the instruments that were used on the first generation of the USM landers were previously used in moorings that were supported earlier from some of the Deepwater Horizon restoration funding. So we had moorings deployed and had these current meters and various sensors installed. And so then when this project came along, the first landers we put together, we repurposed those instruments so that we could make use of them. So that's how a lot of the work is done out here. So we take whatever we have on hand, whatever our partners have, work together, combine resources, and get equipment into the seafloor.
Very cool. There's a lot of partnerships in this work, and it's really valuable to have that. Everybody working so well together. And just in case there's folks watching that don't know what moorings are, can you briefly explain what that means, what that term means?
Sure. I mean, there's a lot of value in measuring what's going on below the surface in the water column. And so that could be anything from the buoys at the surface to the seafloor landers, and then all sorts of instrumentation between the seafloor and the sea surface. So we had nearly about a half-mile long strings of equipment that are anchored to the seafloor but extending up into the water column, as Phil is demonstrating. So in those experiments, we had various sediment traps and current meters and sensors placed along the way. Now, a lot of what we're focused on is near the seafloor. So that involves sticking the landers down there, landing them at the bottom, where you've got all these interesting biological interfaces. You've got the coral down there. You've got the fish that live right over and visit everything. So you can see from the ROV footage, there's a lot of interesting things that happen in the around the seafloor.
Very cool. And some folks might be familiar with the term mooring from using mooring buoys, if they know anybody that goes out and goes fishing or uses a boat and goes diving. One of the other parts of the restoration projects is actually installing mooring buoys for people to use for recreation or for fishing and diving out in Flower Garden Banks National Marine Sanctuary, for example. So that's another part of the project and another way that people might be familiar with that term. But some really cool work we've done also. And so we had a couple more questions here. Another part of that question that we answered earlier is anybody have anything that comes to mind when it comes to misconceptions people might have about working in the deep sea, working in deep sea science or data collection? And if you don't have an answer, we can come back to that later, but wanted to mention it as well.
Oh, misconceptions. I mean,
Misconceptions.
a lot of what people think is probably right on. That we get to explore some of these areas that we've never been to before, and get to see what's down there. Some of what we see is kind of like a barren moonscape, but then when we come upon areas where there's some sort of interesting food for the creatures, then you see a whole community of life down there.
And another thing that people generally misconceive, everybody thinks that a lot of the fish that we see are absolutely massive, like anglerfish, for example, like they're 2 or 3 feet in length. But in all reality, they're this big, but they look to be the most ferocious animals on the planet, and they're really super mean with massive teeth and all these different adaptations. But yeah, the misconception is like scale and size. We see a lot of life down in the deep sea, and a lot of people think it's relatively empty. But in some areas, we have these absolute oases of life that are super vibrant and super functional. They're doing so much, nursery grounds for fish and for commercial species that sometimes we may end up buying from the market, for example.
Yeah, that is a really good misconception to point out, Andy, that people think some of these creatures are so big and they're like so small. But I feel like that makes them a little bit even more like less scary and intimidating, because I think another misconception some people have is that the deep sea is like really terrifying, and the ocean in general is really terrifying. And of course, we should respect its, everything that's in there, and the power that waves have and the ocean has. But also they're so fascinating and beautiful and interesting and valuable. And so instead of scary, we like to think, they're really fascinating. So I think we have one more question before I want to pivot to a little mobile cam action and some show and tell here. So there was one, though, about sediment core sampling that I wanted to ask. What do you look for in the sediment core samples in order to get a sense of the coral's diet? What are variables and their significance? And I don't know if any of y'all can answer that question, or is Jane there? But I know that we mentioned the marine snow and looking for different organic matter. So I don't know if Phil, you can speak to that a little bit.
Yeah, I can answer this question. I don't know what the person is referring to as sediment core. They might be a bit confused. We're not taking any cores of the sediment on the sea floor. We just have a bottle that's attached to an instrument has an opening at the top that's catching particles as they float down. And then we have this carousel that turns the bottle once every month. So the amount of material that falls total in that month gets preserved in this one bottle. And then we get to take the bottle back. We get 12 bottles over a year. And then we can look at the bottle for different isotopic ratios, carbon content. And over a year, you might expect to see some sort of seasonal difference, right? At the end of spring, we're very close to the Mississippi River. So the spring flow is going to be highest at the end of spring as meltwater is produced. And that might cause more material to be delivered to these corals, which could be very relevant to their food supply mechanism. They might be adapted to experience the seasonal supply of food.
I see. Okay, yeah. Because we do know that corals tend to spawn at certain times of year. So it's interesting to think about what they might be eating based on the season. And so for the person that asked this question too, we do also take sediment cores, like you mentioned, and that Phil mentioned, what you saw in the introduction video, where we're actually taking a core and placing it into the sediment on the seafloor and pulling it up. We work really closely with the U.S. Geological Survey on those kinds of sediment coring activities that we do, and to be able to see what is contained in the sediment in various areas around the coral habitats, and also outside of the coral habitats and kind of those like mud zones, which kind of look like moon landing areas. But that can help us actually look at what is in the area and whether any contaminants, et cetera, are present. And like Phil mentioned, carbon content and things like that. We do have some recordings of some sediment coring missions that we've done on our playlist. All
and
right.
about an hour ago, the ROV was actually taking a core. So
There
along
you
with
go.
some coral samples, they took a
Yes.
sediment core, and so that gets processed, and most of what gets taken there is preserved and then brought back on land for analysis.
Yeah, they do these little like disc cuts of them where they just have these little
Exactly
discs
that, yes. And
of
so that's
mud.
everything from geological analysis to biological analysis, looking at the microbes in there, looking at the little worms and critters.
Yeah, all the
But
tiny
don't ask me
secret,
to identify them. I'm just an engineer.
all the tiny secret stuff. All right, so we are going to ask one more question that'll bring us to a little bit of a pivot, and then we'll come back for remaining questions in a few minutes. But Jane asked, what's your favorite critter that you've seen on the lander cameras so far?
Jane asked that.
Oh, I think we know this Jane too.
I
That's
think I know
interesting.
this Jane.
Yeah.
I think we know her.
So one of the interesting things this morning when we went to visit the lander that's been down for a year, it's covered in a lot of different animals. And we saw an anemone growing on the lander itself, and it must have been there for quite some time. So we're excited to see that. It was on the left leg. You can just see on the left side of your screen. It might be a little bit blurry because of all the sediment, but there it is, just sticking out from the vertical round tube leg. There was also an eel living inside the lander, which we saw in the video as well. And I'm actually thinking I might charge it some rent if it's still down there when we pick it back up. Yeah, get some money back from the lander work that we're doing.
But then you also found some giant isopods and a tripod fish and all sorts of neat stuff.
The
And
eel signed a 2-year lease.
So we can show you some of the footage.
Isopods are one of my favorite, and tripod fish are really cool too. I still don't understand the size of them at all, whether they're tiny or you know.
So we've got some videos here that we can show you some of the things that we collected.
Okay,
so this is what the camera looks like before and after deployment. So before deployment, beautifully clean. After deployment, it's covered in lots of encrusting organisms that are growing on it. But here are some of the fish that we've seen. So you can see here, this is the lander that was down for a full year. And just see the pace of life, just how tranquil it is with some of these animals. So we have a fish.
Yeah.
Different types of fish that come into the view. And remember that this is just, we are not seeking these animals out. They are just there. So the magic is that we've just managed to capture this tiny glimpse into the deep sea environment. And we've got some eels coming in the background, swimming straight through the foreground here. And then sometimes we get very cinematic shots, you know, almost as if we're directing a movie.
Don't come for my job, Andy.
And then you can see this one. We've got lots of stuff growing on it, and you can see the actual eel actually tried to eat that particle right there. We're feeding behavior is rarely observed in the deep sea because we only have tiny snapshots of natural behavior.
Wow.
And,
I guess that's another really cool thing that landers can do that like maybe an ROV or divers couldn't, is because the ROV or the divers are entering that habitat and moving constantly through the habitat. So things might move away, might get startled, might hide, whereas the lander is sitting down there for a year staying still. It's like being a really good wildlife photographer. We're sitting still for so long that the habitat and animals can move about you more naturally, right?
Yeah.
So quiet.
There's that tripod fish. It's the first time I've ever seen one in over 20 years in a lander video. So it's amazing. And then I'm going to show you my favorite one. We'll skip ahead a little bit until I show you my favorite video.
I know we back here can't really see the screen as well, but I think we can pull it up too on the live stream too.
So
what was that?
It's a giant isopod.
Okay, we definitely have.
And then buries itself into the sediment. A behavior I've never seen before.
Oh, here we go. We're getting a real look at it right now. Whoa. That's so silly. Do we know if they actually burrow underneath to hide?
Oh, that's my favorite. headless chicken.
Headless chicken.
Oh. Oh my.
And you can also see jellyfish as well floating around.
Oh, here we go. This is the headless chicken monster. Is that what you said?
Yes.
Yeah.
Whoa. I've heard of
Yeah,
those
and different
things.
output.
And you got your gummy bear supply there, so everybody's happy.
Full snack supply.
Amazing. And on that note, we got a question. Hey, Phil, what's the best thing you've eaten so far? I think everybody can answer this question, but it was specifically asked to Phil.
Wow, this person must know me really well. Oh, it's Jane. It's my
Another
aunt.
Jane. Another
It's my
Jane?
aunt.
Oh,
What's the
your
best thing I've eaten? That's a good question. I just had a steak for lunch. That was pretty good.
fancy.
They have this protein ice cream on board.
Oh, that's really good.
You can get 9 grams of protein in this little cup. The calorie to protein ratio is not great, but I ate that with this blackberry. Oh, Jane would like this. They had blackberry. What was it? Blackberry
Sorbet?
crumble. Blackberry
Oh.
crumble, and they kept it heated up. So then I had the heated blackberry, and as you can see, I can just like talk about food constantly.
Yeah.
Yeah, they
But-
also had ice cream sandwiches, and I believe they had 2 grams of protein.
Excellent. Good.
Right.
We're all getting your
I
protein.
wanted to answer this because I'm really excited about this. I've been vegetarian for 11 years. One of the cooks is vegetarian, and the other one has worked in a vegetarian restaurant prior to coming to the Nancy Foster. I would say this cruise is probably the best food I've ever eaten, vegetarian-wise, so I'm super happy. Today I had curry. It was delicious. Yeah, every meal I'm constantly like so happy because I'm like I can finally eat like good food now. Don't have to cook it myself, so that's been a big plus for me.
I love that they're making sure everybody's fed and taken care of. And I love how Phil mentioned the protein ice cream after saying he had a whole steak. Like, I don't think you needed the 9 grams in the ice cream, but I love that you had that.
Very enthusiastic. For those
Yeah.
who haven't been to sea, like eating is very important.
Yeah,
You know,
you're
you
working
feel-
long
You
days.
feel very nourished after. You know, it's important to have good, healthy food.
The chefs are very beloved on boats.
Yeah, they
As
work so hard. They work so
they
hard.
should be. All right, I think we might. We have one more question here. I think this is a good question for Max. Are there any opportunities to go into ocean? I think that was maybe supposed to say research. As an aspiring welding engineer.
Oh my goodness! Yeah, like Andy was mentioning that that the lander design itself, we have to be careful what materials we choose. Yeah, you guys got a bad batch of stainless steel on one of the early launches, so so some of the equipment came back, and the fasteners were just dissolving away. So so they had been purchased with a certain specification, and something didn't quite live up to standards. So so the materials are very important to us. The materials of the housings. I've just recently spec'd out a housing for a piece of 5,000 meter equipment, and it's really not much different in size and weight with another material. It's just a different alloy of aluminum. So so yeah, super important. We've had some good aluminum welders working on the Albex landers and the USM landers to get them all put together. And there's also plenty of machine shop work that goes on as well to cut out some of the shapes we need. And so definitely so. If you're in an environment, especially near a university that's doing research work, they're always interested in fabricators that are putting together some of this equipment.
Yeah, and I know there's underwater welding as well. That's like seemingly a very high-paying job that I've heard of. My oceanography teacher in high school was an underwater welder on the side.
Lucrative, but dangerous.
Very dangerous, yes. Very. If you're an exhilarating type of person and you like to have what I call type 2 fun, very exhilarating, then that might be the job for you. All right, I think we're just about out of time here. So we have a shout out from the port engineer saying, really cool to see Foster doing such a cool project. Hope you're having a good time on board. Love that. As you're bragging about the food, definitely having a good time on board. Hard work, but delicious food. All right. And then I think we have a great question here to wrap up with. So I have one more quick question about the lander so that everybody kind of understands as we put everything out and as we're taking it all back, how long does it take you to process all the data from a lander after you've recovered it?
How long to process data?
It depends. It very much depends on the volume of data, how long is the lander out, what kind of data is it collecting, can we use certain tools to help us process the data? So, for example, video data, a lot of people are using machine learning or AI tools now to help process that data, but we know so little about the deep sea that we're still doing a lot of it manually.
Yeah.
So we usually take about 6 months to a year to really work up all of the information that comes off a single 1 year long lander deployment. So it is a big effort to do.
But I bet you're getting a lot of really cool information. And at least you get to see some cool videos and photos pretty quickly, which is a nice little reward to keep you going through the data. All right. I think we have one last good question to wrap it up, and it's a really nice one to end on. What's your favorite thing to do on the last day of the cruise? Mine is for sure to eat another ice cream from the ice cream freezer and make sure I took some great photos out on the deck of the beautiful sea. What about y'all?
Last day of the cruise.
Yeah.
Last day of the cruise. I can answer the question first. The great thing about the last day of the cruise is we have some data to work with. So what I do is I give it to my students to start working on for their thesis. and then we wait until they're finished.
Well, I can't really follow that with anything else, but on the last day of the cruise, I take the data and I work it up.
And you get an ice cream.
And I get an ice cream. I like to say goodbye to everybody.
Yeah, definitely.
This is my first lander cruise, but last year I got up early to watch the sunrise one last time. And that's my goal, is to wake up early for the sunrise and then work on the data after.
And yeah, with the CTD, you're probably one of the first people up usually. So you have to get up even earlier sometimes than others because that's usually one of the first things that's done. So yeah, it'll be worth it.
I got up 5:30 this morning and yesterday. Saw the sunrise both days.
You're on track then. What about you, Max?
Tee us off.
Oh, all that. I just sleep on the last day. It's exhausting. So on
the transit back.
Get the one last steak and lobster or whatever, and maybe 9 grams of protein from the ice cream, and then sleep while everybody else is transferring data.
Yeah. What a treat. And we got some comments that sunsets are popular also. I got to see a bit of a meteor shower last time I was at sea. It happened to be in August last, and it was really cool to be able to see that too. So sometimes you get treated with seeing some really cool, dolphins or maybe whale, or maybe, if it's nighttime, meteor showers or nice stars. So, well, enjoy the rest of your mission. I will be seeing some of you probably on Tuesday, maybe for the next one. And yeah. All right. Well, thanks for joining us today. And I'm glad we had some great questions in the chat. And
the ROV is coming up right now. So some of us have to get out on deck and get that recovery. So getting back to science.
Get out there, get back to work. We have the live ROV feed here just showing the water column as it's coming up on its way. Folks saying hi in the chat. And thanks for joining us today, y'all. I'll let you get back to work as I do a little outro here and wrap up the stream for everyone online.
Right.
Thanks, y'all.
Bye,
See you soon. All right. So during this program, we want to take some time to really focus on the work that those folks are doing right now on this particular mission. But I wanted to wrap up just for a moment by reminding everyone this mission is just a snapshot of the Mesophotic and Deep Benthic communities restoration projects in action. So the extensive high resolution seafloor mapping we mentioned in the beginning in that video, deep diving into understanding these seafloor communities and how they're connected, groundbreaking coral propagation studies in labs and at sea, removing marine debris and the reduction of other threats, and efforts to connect people to these habitats are all crucial components of the one goal to restore these deep Gulf habitats that were injured by the Deepwater Horizon oil spill. So please check out our other live stream recordings, our upcoming live streams, publications, and online resources to learn all about our efforts at sea and on land in our coral labs and with our partner organizations, aquariums, museums, and universities. We even have educational materials for all ages available to download for free at marinesanctuary.org/NDBC. And last but not least, we'd love to get your feedback on today's program. So if you did it at the beginning of the program, no worries. You're also welcome to probably do it again if you'd like to add anything. But please fill out the quick survey. That'll be linked in the chat. We'd love to hear from you. All right. And thanks for joining us today. Hope to see you soon. I'll be back on Tuesday.